Today we're going to be talking about 4C, add, subtract, multiply, and divide complex numbers. So we're going to start with adding and subtracting. Adding and subtracting, we're going to treat these complex numbers, imaginary numbers, like I is just a variable. So just treat it just like a variable. With addition, when you're adding, you're just adding like terms. So -5 plus -7. -5 plus -7 is -12. We also have -8i plus -8i. If you put those together, you get -16i. There are no other like terms to put together, so this is your final answer. So subtraction. You're going to be doing the exact same thing. You have like terms. We have -8. We are subtracting -2. -8 subtracting -2. So let's write that. -8 subtracting -2. So that's going to be -8 plus 2, which is -6. We also have positive I subtracting -5i. So we have positive I subtracting a -5i. Subtract the negative is a plus, so we have I plus 5i is 6i. Those are all like terms are together, and that's their final answer. If you'd like to do this in a different way, we can do this. It's like the stacking method. You're subtracting -2 minus 5i. So if you want to look at it like this, you have -8 subtract -2, so that's adding, so that's -6. We have I for subtracting again, -5, so subtract the negative is plus. So we could also do it this way, same exact way, just instead of horizontally, like up here, we're doing it vertically, simplifying. With multiplication, we have, you're just treating it. This is FOIL, so 5 times -8, and then 5 times 5i, so plus 5 times 5i, and we have -4i times -8, and then you have -4i times 5i. Let's put these together. Each term, you have -40 plus 25i, 2 negatives plus 32i, and -4i times 5i is a -20i squared. Let's simplify this. You have -40. You have like terms here. Put the like terms together. We're adding these together, so that's positive, so plus 62. Just kidding. 57. 57, not close. 57i. And then we do have to be careful here. Remember that I squared, anytime you have an I squared, that is equivalent to -1. So we have -20 times -1, which is positive 20. So let's keep looking here. We have like terms again. -40 plus 20 is -20. Plus 57i, and we no longer have any like terms. This is our final answer. With division, we have two different types of division. We have, in example 4, a monomial, one term in the denominator. In example 5, we have 2 binomial in the denominator, so we have to treat them differently. So here, this is a monomial, one term. What you do for this is just, there's an I in the denominator. You cannot have an imaginary number in the denominator to be simplified. So you cannot have imaginary in the denominator. All you do with this monomial is multiply by I. So we multiply the numerator and denominator by I. The reason why we do I divided by I is because I divided by I is 1. So you're really not multiplying the original problem by anything new. It's multiplying by 1. If you multiply anything by 1, it's okay. 3 times 1 is 3. So we have 1 minus 2i over -4i times 1. That's the same thing. So what we do here, distribute in the I. So we have 1 times I I. Negative 2I times I is negative 2I squared. And then you have on the denominator, negative 4I times I, negative 4I squared. Let's simplify this numerator and denominator. First we have I, can't simplify that. And 2I squared, remember that I squared is equivalent to negative 1. So we have negative 2 times negative 1, which is positive 2, so this becomes plus 2. And then in the denominator again, remember we have this I squared, which is equivalent to negative 1. So we have negative 4 times negative 1, which is positive 4. I'm looking here to see if there's anything I can simplify. We have I plus 2 divided by 4. 2 divided by 4 I can simplify, but there's no coefficient on the I that I can simplify with 4. So I will not simplify that any further. That is our final answer. There is no imaginary number in the denominator. So that was my goal there, was to simplify. Example 5, we're simplifying, and we have now a binomial in the denominator. Now the binomial, we do something a little different than when there was a monomial like in example 4. We look at our denominator. We have an I in the denominator, and this I, that tells us we have to get rid of it. And how do we get rid of I? We have to create I squares. But with a binomial, you multiply by, and actually the binomial again. But we switch the sign of the imaginary number. So right here it's a negative 8i, so we're going to multiply by positive 8i. So negative 9 plus 8i, and by doing this, we'll see that we will actually cancel out the I in the denominator. So we have on the numerator, 1 times negative 9 is negative 9. 1 times 8i is 8i. In the denominator, we have binomial times a binomial. So let's work this out one at a time. Negative 9 times negative 9, 81. Negative 9 times 8i, negative 72i. Negative 8i times 9, negative 9i is a positive 72i. And negative 8i times positive 8i is negative 64i squared. This looks terrible in the denominator, but it actually is going to clean up nicely. It always does. The numerator, nothing in the numerator can be simplified. We just keep that the same right away. So now we're just looking to simplify. That's all we're doing here. We have negative 72i plus 72i, those cancel. So we have 81 in the denominator. Remember that I squared is equivalent to negative 1. So we have negative 64 times negative 1, which is positive 64. Well, let's clean this up even more. The numerator stays the same. The denominator 81 plus 64 is 145. We look at all the terms, negative 9, 8, and 145. Are they divisible by anything in common? And I can't see anything that's divisible. We have no more imaginary number in the denominator, so that is my final answer. Example 4 will be your quiz when you walk into class. Example 4 will be your quiz when you walk into class. After the quiz, I will answer any questions you guys have, so please write them down. Thank you.